So just a relatively short one from me this time, which I know is rare. But this is about algebraic fractions. Because in order to do partial fractions, we need to be secure on our algebraic fractions. So, multiply fractions. Let's imagine I have 1 over a squared plus 6a plus 9 times by a squared minus 9 over 2. Now, when I'm doing algebraic fractions, the first thing I will do is factorise them. I want to simplify them as early as possible because the likelihood is I'll be able to cancel. I always factorise what I think is the easiest first. For me, spotting a difference of 2 squares is the easiest. I'm not going over things like that at the moment. Then I'd factorise this because I know that the likelihood is that these will cancel. There will be something here that will also be a same bracket on the bottom. These are both positive, so clearly both my brackets will be positive, and it's a squared, so it'll be a at the front. So I'm clearly going to have a plus 3. 3 times what makes 9? Well, it's 3, so actually nicely it's a perfect square. So that means before I even multiply, I can cancel across the top and the bottom. The reason I can do that is because if I were to multiply it across and do it all in one fraction, I would have a plus 3, a minus 3 over a plus 3, a plus 3 times by 2. So because I'm multiplying all of the numerator and denominator by a plus 3, I can cancel. And then you're left with a plus 3 times by a minus 3 over 2 lots of a plus 3. Don't need to expand it. There's nothing else I can simplify any further, so that's it. Second example, now looking at an adding and subtracting type question. Focusing on subtraction because it's easier. When we add and subtract normal fractions, what must be the same? The denominator, I hear you all cry, absolutely, the denominator must be the same. If we are not sure what our denominator should be, multiply the denominators together, and in algebraic fractions that's what you have to do. So in order to keep these fractions equivalent to what they are, all of this needs to be multiplied by x plus 1. So we get 3x plus 3. You could leave it in brackets, it doesn't matter. And then all of this needs to be multiplied by x, so 2x. And I'm going to take it all into one fraction. Simplify, collect like terms, and I'm going to get x plus 3 over x times by x plus 1. Now, the one thing you have to be careful of when you're adding and subtracting is this, and I'm going to use, you can still see that question, use a very, very similar example to this. So imagine I have 3 over x minus 2 plus x over x plus 1. So we're going to do the same thing. It's going to be making the same denominator. 3 times by x plus 1 is 3x plus 3. 2 plus x all times x is 2x plus x squared. So now if I want to put it as one fraction, 3x plus 3 subtract. Now if I wrote 2x plus x squared, I would be wrong. Because clearly I'm subtracting all of this. Because I'm subtracting all of it, effectively this comes first. So that has to be in brackets. Because clearly if I were to expand those brackets, I'm going to have a negative x squared. Whereas by not putting the brackets, I'm leaving it as a positive x squared. Oops. Which then clearly is wrong. The reason I didn't put brackets here is simply because it was one term, so it doesn't actually matter. And if that term was negative, then this would become a plus anyway, and so the brackets wouldn't necessarily matter. Obviously, I could have put brackets, but if I didn't need them, then I don't want to put them, really. So please be careful. Again, from the paper I marked, pure paper 1, if you've seen the proof of contradiction video, you'll know I was an examiner for pure paper 1. in 2019. And question 3 was a quotient rule question. Now you, for those who are in my school, who this is related to, obviously I'm saying this as if now maybe other schools will watch this, I don't know. Those at my school haven't done the quotient rule yet, which is fine. But effectively there is a subtraction. And in this particular exam question, if you didn't put brackets in when necessary in this exam question, you lost a mark. Now it didn't matter whether you recovered it later on, that means you did the right mathematics given that brackets should have been there. If you didn't put those brackets in, you lost a mark regardless of that. And if you didn't recover it, i.e. you made an error, like if I'd left this, I would have had minus 2x and then positive x squared if I hadn't put the brackets in there. Then they actually lost 2, potentially 3 marks. So brackets, and I'm sure your teachers, wherever you've come from, will have moaned at you about putting brackets in. Brackets are really, really important. So, key things for algebraic fractions: factorise, treat them as normal fractions, as in the method is the same, and brackets.